basic concepts of database. What is database? What are the how the database are used? How we can write a query? What is a table? What is a row? What is a field? All such topics we'll try to cover in this. So this is a database basic concepts. We'll try to understand few fundamentals of database, few terminologies of data, few terms of database, right? So let's see. So the definitions, few basic definitions of database. What is database? Okay, what is database? A collection of related data. Okay, database is a collection of related data. Okay, when I say related data, what it means? For example, I want to develop a database for school. For example, I want to develop a database for school. When I say I want to develop a database for school, then all the information should be related to that school. All the data should be related to that school. So that is called a school database. So I can name it as school database. Okay. So that is related data. So that is school related data because I am developing a database for school. So that's why we define as a collection of related data. Okay. That's why we define as a collection of related data. The data is related to that particular entity or that particular field or that particular business, right? Data, and next one is database management system. What is database management system? A software package or system that facilitate, create, maintain of computerized data. Okay. See, now I developed a database, right? I developed a database, but in order to maintain the data, in order to maintain the database, okay, in order to maintain the database, we should have some system or some software. We should have some system or some software which is used to maintain those database, right? Which will maintain those database. That is called as database management system. It's a software or a package that is used to maintain a computerized database. Okay, computerized means the database in a computer or coded. Okay, not the manual, the records or not the manual records that ledger and all. No, it's a computerized database. Okay, to maintain or to facilitate the database, we go for database management system. It's a set of softwares or packages which facilitate or maintain, which facilitates or maintains the database. Okay. Then what is database system? The database management software together with a data itself. Okay. So these all database softwares together, okay, is called as database system. Okay. The systems which is used to maintain the database is nothing but a database system. So these are the few definitions with respect to database. Right. Database object. What is this database object? A table is a database object or a structure with the data is stored. Okay. A table itself is a database object. A table itself is a database object. Okay. Then what is this table? A table will contains rows and columns. A row is a table is a tuple, and the column in a table is an attribute. Okay. So table in a database is called as an object. Table in a database is called as an object structure where the data is stored. Okay. So this is structured in such a way that data is stored in the table. Okay. Then how this is structured? How this table is made? How this table is created? Is a collection of rows and columns. Okay. It's a collection of rows and columns. It's a collection of rows and columns. Okay. Tuple is a row and column is called as attribute. Okay. Column is called as attribute. If I say school, school is a database. Okay. School is a database. In that school, table student is a table. Okay. Student is a table. So what this student table contains? Student number, student name, student phone number, student address, every related with student, we have some table. Okay. Similarly, we have something called as faculty. Okay. There would be in a school we have faculties. So we have a table for faculties. So all these tables are tables are the objects of database. All these tables are the object of database, and each and every table is a collection of rows and columns. Is a collection of rows and columns. Row is a tuple and column is an attribute. Row is a tuple and column is an attribute. Right. So, database system environment. So, this is how it looks, the database system environment. So, user program, application program query. Okay. So, the end user will write some query or will write some program. Okay. We will write some query or some program to get the data, to get the database or to get the data. Okay. So, the query will flow to software requirement programming. There will be some softwares which takes the query, which passes to the database, connect to the database and process it and gives the result. Okay. Gives the result back. So, this is how the simple architecture looks like, the simple architecture looks like. So, there would be an application, there would be a software, and the database is the symbolic representation of database is the below one, right, the below one. Okay. So, logical structure for database. Okay. So, database again to define or to develop a database, there should be some, we do have some structures. Okay. We do have some structure. In any structure we can develop a database or we can create a database, right. So, among those are tree structure, relation structure, network structure. Okay. Tree structure, relation structure, network structure, and this is a logical structure. Logical structure in sense we cannot see that is a coding part. Okay, that is a coding part. Tree structure, relational structure, and network structure. The most common related database is Microsoft Access and Oracle. Okay, the most common relation database is Microsoft. Let's see each and every structure. Okay. So, relational data model. A relational data model allows the definition of structure, storage and retrieval operations, integrity constraints. In such a database, the data reaction is between the organization in the table. Okay, the data relation is between the organization in the table. Okay. So, relation database is defined allows the definition of the structure, definition of the data structure, and the storage and retrieval and integrity constraints. Okay. So, relational database is defined as data structure, storage and retrieval operations. Okay. Data structure and storage and retrieval operation. So, say suppose a database have multiple tables. Say suppose a database have multiple tables, but it's just not the individual table. Okay. Each table has one relation. Okay. To communicate, to integrate two different tables, we will form a relation. Okay. To integrate two different tables, we form a relation. That is a relation data model. That is a relation data model. You can see in this slide. In this slide, you can see relation structure. We have table called course. We have table called session. Okay. We have table called course. We have table called source session. So, these are two different tables in a database. These are two different tables in a database. But to form relationship between these two tables, I mean to say to link these two tables, to map these two tables, we have one common column called course number. Okay. If you see in a table course, we have a column called course number or the field called course number. If you see in a session, we have same column course number. Okay. We have same column course number. So, this is a column which will map. This is a column which will map these two tables. This is a column which will map between which is used to map these two tables. Okay. Which is used to form a relation between these two tables. Okay. Which is used to form a relation between these two tables. Okay. So, when you want to get a data of course and session, so with one query, with one selection, one select operation or one insert operation, you can get a data, or you can insert a data, right. So, relational structure is nothing but two different tables. We are interlinking, or we are forming a relation between both those. So, in this example, course number is one column which is used to form a relation between these two tables. Okay. Hierarchical model. So, in the relation model, two different tables is form relation between with use of one column, one common column. Similarly, we have something called as hierarchical model. It is a tree structure. Hierarchy is a parent-child data segment. Okay, it is a tree structure. It is a tree structure. Okay, it looks like a tree structure. It is like a hierarchy is nothing. Hierarchy is like a parent-child hierarchy. Hierarchy is nothing but parent-child hierarchy. So, we will be having some parent table and we will be having some child table. So, all the parent table would be comes in a child table. Hierarchy model structure data has a tree records, which each record have a parent record and many child record. Okay, each record will have parent record, many child record. For each single parent record, there might be many child record. So, that is a tree structure. That is a hierarchical model. Okay, you can see the tree structure. This is how it looks like. Okay, this is how it looks like. Here, alias and top is nothing but a parent. In that you have multiple childs. Okay, for top you have 3 childs, and for so forth. If you go down, if you drill down, those are the childs. Okay, those are the childs. So, one record for parent will have multiple records for childs. Okay, we have multiple record for childs. This is how the tree structure looks like. Okay. Network database model. Network database model organizes the data network, and the network model allows each record to multiple parents and child records. In the tree, one parent, multiple childs, but here multiple parents, multiple childs. Okay, the structure will be, we will be having multiple parents, and that multiple parents would be mapped to multiple child records. Okay, multiple parent records to multiple child records. Let's see how it looks. So, this is how it looks like. Okay, network structure looks like we would be having multiple parents record would map to the multiple child record, So, this is how the structure looks like. Okay, this is the network structure. So, database types and physical location. So, based on the location or based on the scope of the database access, they are again classified. Based on the scope or based on the location, physical location, they are classified based on the scope. When I say scope, how many can access, or how we can access. Okay, so based on that scope, based on access scope, these are again classified. Shared database, shared by user in an organization within one location. So when I say based on the location, these are classified. So shared database are placed in one single location where multiple users can share the database. Okay, shared database is placed in a single location where multiple users can access those database. That is shared database. The name itself says shared. So multiple users can share those database. Typically found in a local area network. When local area network, nothing but within a building or a couple of buildings. Okay, so that is the limit is within a building, right? So that is shared database. Similarly, we have something called as distributed database. So shared database is within building. Distributed database is the database would be in different places. Data stored in a different computers in different places, like client server architecture. This is called as client server architecture. So in different location we can get a data. In different location we can get a data. So that is called as distributed database. Two types are partitioning, duplicating. There are two types, two methods, partitioning and duplicating, right? So distributed database, the database would be stored in a different location. Okay, like client server architecture. Here server is nothing but providing the resource. Client is the one who consumes the resource. Okay, client is a entity, or client is a component, or client is a computer which serves the resource. Or server is a computer which serves the resource, and client is a program which consumes the resource. Okay, server is the program which serves the resource, and client is a program which consumes the resource. Right. So it should be a distributed environment. So one system one system in one location and one system in another location. So we are retrieving the data from different systems which are located in different areas. Okay. Centralized database, okay, centralized database. So there would be one database at one particular area, okay, one particular area. So all our client would be mapped to that database. All our requests would be mapped to the database, right? All our requests would be mapped to the one centralized location, one common area, one common location, the data would be stored, and from that common location we can able to get the database by network, okay, communication networks, via communication networks, right? So centralized itself, the name itself says centralized. So this is fixed at one particular location. This is fixed at one particular location, accessed by different computers in different locations. So that is called as centralized. The meaning itself says centralized. Okay. So one fixed area, from the one fixed area, multiple computers will access from this particular location, right? That is a centralized database, right? Okay. Fundamental database concept. So far we gone through. Based on the physical structure, the database are classified. Okay, based on the physical structure, the database are classified. One is shared database, one is distributed database, one is central database, so on. Right. Similarly, let's see what are the fundamental concepts of database. What are the fundamental concepts of database? Entity. What is entity? Person, place, object, or event. If you take person or place, an object, event is called as an entity, stored as a record or a table row. Okay. Entity is stored as a row. Each row in a table is called as an entity. Each row in a table is called as an entity. Attribute, characteristics of entity, stored as a field or a table. Each field or table column, each column in a table is called as an attribute. Each column is in a table is called as an attribute. Suppose, for example, student is an entity. If say student is an entity, what is the attribute? The characteristics of student number, student name, student address, student subjects, all that comes under attribute. Okay, all that comes under attribute. So combination of this entity and attribute are nothing but rows and columns. Okay, rows and columns. Combination of this entity and attribute forms a table. Okay, combination of this entity and attribute forms a table. Why? Because the definition of table is collection of rows and columns. All right, collection of rows and columns. Here, row is an entity and column is an attribute. Okay, row is an entity and column is an attribute. So collection of entity and attribute is nothing but a table in a database. Okay. Of course, we saw what is database and what is table. See, just I explained. A collection of related records or rows and columns is called as a table. Okay. So when you drill down, record, collection of fields, that is rows. Rows is an what is record? Is a collection of fields in a table, that nothing but a table row. What is field? Collection of characters. Collection of characters, nothing but a column, table column. What is character? Single alphabet, numeric, or other symbols. What is character? Character might be anything, might be alphabet, might be numeric, might be symbol, any kind. So those are called characters. So these are the few fundamental terminologies, or these are few fundamental concepts of database. If someone asks what is table, collection of records, then what is record? Collection of fields. Then what is field? Collection of characters. And what is character? Collection of alphabets or numbers. So this is how it will be drilled down. Okay. All collection of tables is nothing but a database. Again, all collection of tables is nothing but a database, right? So again, if you go to each and everything, what is field? So collection of characters. B is one character, R is one character. So all these collection BREIMER forms a field. Okay, and that field has some name, that is called as last name, right? Attribute of entity, right? That is called as field is an attribute of entity, right? Similarly, record, bunch of fields. So each and individual field, like file first name, last name, sex, weight, these are all fields. So this collection of fields is nothing but a record. This collection of fields is nothing but a record. Table. So each and every record, so one field is one record, multiple fields, so multiple records. So all these records, this collection of all records is nothing but a table. This collection of all records is nothing but a table. And remember guys, here a table is a group of related entities. Okay, related, and when I say related entities, if you say collection of, if you say student, then the record should be specific to student. If you say faculty, the records should be specific to faculty. Okay. A bunch of database, a bunch of tables is collection of database. Okay. We saw records, we saw fields, we saw records, we saw tables. Now a collection of all the tables, a collection of tables is a database. Okay, a collection of tables is a database now. But database are not just a bunch of tables. So the database also includes relationship between the different tables. Okay, it's just not collection of tables. It's just not collection of tables. The relation among those tables, If you see, we have a table called order, customer, products. Order is a table, customer is a table, customers is a table, products is a tables. Okay, we have 3 tables. Now the relation between these 3 tables. Okay, customer orders something, right? Customer orders something. What is the something? It might be product. Okay, customer order products. So these, we have some relation among these 3, right? Okay, we have some relation among these 3. So not only tables, it also forms a relation among those tables. Okay, not only table, it also forms a relation among those tables. Types of relation. So when I say relations, we have multiple types of relations again. We have types of relations again. So we have, just now we saw three different tables, and we have some relation, right? We don't know what is that relation is. Now let's drill into what exactly the relation is. What are the types of relation? Okay, the one type is one-to-one. Okay, one-to-one relation. Okay, one-to-one relation. One-to-one relation. Thing A, thing B. For example, you can see the relation one-to-one. Okay, A to B, right? That is one-to-one relation. Man to woman, that is one-to-one relation, right? Okay. Of course, one man will marry one woman, so one-to-one relation, right? Consider the thing to A, thing to B, right? And thing B become relation more than one thing A. If 2 answers are no, then it is an one-to-one relationship. So we have some criteria to know to say this is a one-to-one relation. Analysis technique. We have some analysis technique to know one-to-one relation. Consider thing A and thing B. Okay, thing A and thing B. Can thing A be relation to more than one thing B? Can thing B relation more than one thing B? Okay, if that is the case, then it is an one-to-one relationship. That is called as one-to-one relationship. One-to-many relationship, right? One-to-many relationship. Faculty, one faculty, many students, right? One faculty will teach many students. One faculty will teach many students. That is one-to-one, one-to-many. Okay, that is one-to-many. Only the same 3 analytical techniques to identify those. So one faculty have many students, that is called one-to-many relationship. One faculty have many students, that is called one-to-many relationship. Similarly, we have many to many. One course have many students. Okay, one course can taken by many students, and many student can learn many courses, right? If say Java, okay, let me take one example. Java is one course, right? Java is one course. So Java can A can join Java, B can join Java. Okay, B can join Java. Similarly, from Java side, some course side, when you say some course side, Java has A, B, C. Okay, so this is many to many. So many students can take many courses. Many courses can have many students. Okay, many students can take many courses. Many courses can have many students. That is called many to many relationship. Okay, many to many relationship. How to model a relationship? Okay, how to model a relationship? Okay, how to model a relationship? We have, as an earlier discussion, we have order table, we have customers table, we have products table. Okay, we have order table, we have customer table, we have products table. How to map this relationship? How to map this relationship? In order to map this relationship, we will be having common fields. We will be having common fields. If you see here, if you see in this slide, these are the common fields. Okay, these are the common fields. In customer table, let me go back to the previous slide. In customer table, customer COID, CID, OID, CID, PID. These are the three common fields you will have in other table as well, right? CID, customer ID, PID, product ID, OID, order ID. Okay. So with help of these three columns, we can map these three tables. With the help of these three columns, we can map these three columns, three tables. Okay. So this is how it would be. This is how it would be. Find the name, hiring, date of the manager working on salary manual project, right? So how this is identified? This is identified by the unique ID. This is identified by the unique ID. Here in this case, department number is one unique ID. Department number is one unique ID. Based on the department number, and it would be identified. It would be identified. Okay, it would be identified. Now the next one is database management approach. Okay, consolidate data records into one central database that can be accessed by many different applications. Right. So how the database management approach is? The database consolidated into centralized location. The database is consolidated. The data is consolidated into centralized location, so that many applications can access those data. So that many applications can access that data. Okay. So that many applications can access that data. This is a collection of data. It's a collection of different data in a centralized central database, in a centralized way, in a central database, so that many application whichever want to access those data can access it. Okay, can access it. Okay. So it means that we are clubbing all the data into one location, and that location can be pointed out with many applications. Okay. If Java application want to access data, there will be some address, some point, some location which connects to the database and get the data. .NET application want to access the data, there will be some point, some location, some area which connects to the database and get the data. Okay. So this is how the database is organized or managed. This is how the database is organized or managed, right? So if you see the program here, there is a centralized. The below database is a centralized, and the above one is multiple database. Okay. So in various database, the various database are pointing to one centralized location. The various database are pointing to one centralized location. When you want to access some data, you can directly get the data from centralized location. Okay, you can directly get the data from centralized location. Right. So this is one of the example of centralized location. Okay. Database management softwares. Okay, database DBMS, database software that controls the creation, maintenance, usage of database. Okay. As earlier discussion, we said we had a definition of DBMS, right? Database management system. The name itself says DBMS, nothing but database management system or database management softwares. Okay. The softwares that manage the database. The softwares that manage the database. What do you mean by manage? Creation, maintenance, usage of data. Okay. Creation, maintenance, or usage of data. These all would be managed by softwares. These all would be managed by softwares. Few softwares like Oracle, Microsoft, or few softwares that is used to manage the database, right? That is used to manage the database, right? So those softwares are called database management systems, right? So database definition. So database definition, large graphical tool defines entries relationship. This already we saw what is the database definition. It's a collection of entities, a collection of tables. It's a collection of tables, relevant data. It's a collection of relevant data is nothing but a database. Application development. Okay, graphical to develop menu, data entry, forms, and reports. Okay, application develop. So this is a database component. This is a database software component. In a database software component, we have something called as database definition. Languages and graphic tools define entries, relationship, integrity constraints, and authorization rights. Okay. So what this software will do is, it manages the relationship integrity constraints. When I say integrity constraints, based on some condition, you need to get a data. Based on some condition, you need to get a data. And it also manages the authentication, authorization. Okay, it also manages the authorization. So it provides the user ID password, or it provides some authentication to you, so that you can connect to the database. Only the relevant user can connect to the database. Only the appropriate user can connect to the database. Apart from that, it provides the access based on the user. It provides the access based on the user. What I mean to say is, access is, if you want to provide only read-only access, you can provide. If you want to provide only write-only access, you can do that by using this DBMS software. By using DBMS software, you can manage all these access criteria also. You can manage all these access criteria. You can manage all these relationships, right? Application development, a graphical tool that develop menu, data entry, forms and reports. Okay. Then what is there? There is something called as application development. This is a graphical tool. The graphical tool means you can this is a UI where you can click, or you can select, or you can click a button. You can select some option from a menu. Okay, you can pass a query by clicking on selecting some menu or button, right? So that is nothing but application development. Application development nothing but by using some menu options, by using some buttons, you can get a data from database, right? Transaction process, control to prevent interface from simultaneously users, and control to recover lost data after a failure. Okay. So what else this software can do? Transaction processing. It does the transaction processing. What transaction processing it means? So it controls the prevent interfaces from simultaneous users. For example, I want to access some data. Okay, I want to access some data. So the same data some other user want to access simultaneously, right? Same data simultaneously some other user want to access. So this software will provide the scheduling, or will provide the synchronization, will provide the scheduling a priority. It sets the priority. It passes the relevant data to relevant person. It passes the relevant data to relevant person. Control recovery lost after a failure. This software also provides. If there is some issue in the database, due to which the data got lost, then it will recover the database. It recover the data. Database tuning. Tools monitors and improve database performance. And it also improves the database performance. These softwares will also improve the database performance. This all comes under maintenance. Actually, this all comes under maintenance. So DBMS is software which will do all these functionalities or facilities, which provides all these facilities, right? Database interorganization definition. Capability of database to report information of the database, response to end user requirements. Okay. Capability of the database to report inform from the database in response to end user requirement. Okay. So what this is, when you pass a query, when you request something, right? When you request something, it will provide the report or information to you. It will provide the report or information to you in a form of response. Okay, in a form of response. Okay. So for that, how to pass a request? We have something called as query language. Okay, we have something called as query language, which is immediate access to data requests. Okay, by using query language, by using few query languages, we can pass a request to the database. Okay, by using few query languages, we can pass a request to the database. Report generator allows quick, easy specifications of the report format for information user have required. Okay. So this will generate a report format for information used for the required. Okay, easy specific. It will generate the report based on the user input or based on the user request. Okay. Natural language versus SQL query. Natural language is nothing but a simple English command, which you can see the example. What customer had no recourse last month. Okay, so that is one query. That is one query which will pull the report. And we have something called as SQL queries. You can see select statement, right? Select so and so fields from the customer, right? Where condition. Okay, so we have something called as select from where. Okay, select is a SQL query to select the records from the database. Okay, from says from which table you want to get a database. Okay, where if you want to put some condition, where employee, so I want to select the details of employee whose employee ID is 1234. Okay, I want to get a details of employee whose employee ID is 1234. So in that case, what I will do is select employee or employee name or employee address or whatever from employee table where employee ID is equal to 123. Okay, so this is how we syntax a query. This is how we will write a query. So okay, this is how we will write a query. Data definition language. This data definition language DDL, we call it as DDL. In short, we call it as DDL. If you see in the screen, data definition language, it describes the relationship between different data. Describes the relations between different data. What kind of data is? How many attributes are there? What is the relation between those? Okay, what is the relation between those? Say suppose attributes instance file name. If I say employee name, is a character or is an integer or is an how many? If is a character, how many characters? If it's an integer, how many integer? How many length of the integer? So all kind of stuff is defined in data definition language. Okay, all kind of stuff defined in database definition languages. Right. Data directory entry, a more detailed description of the database in the database in the database definition languages. In the database definition language says the type of database, the size of database, if is there any relationship, all that is defined in the database definition language. Whereas in database dictionary entry, more information would be described in a data dictionary entry. Specific data type and range, assistant programming in the understanding the database, so that someone can understand what exactly the database is, what exactly is about the database is. Okay, what exactly the fields are, what exactly the attributes are defined in the database. So with this information, the user can understand, the developer can understand what exactly it is. Okay, physical and logical view. Database concepts of physical and logical. Concurrency control, queries, creating, deleting table. Okay, so if you see these are the activities we can do. We can query a query. We can create a database. We can delete a database. We can do. Okay. So this is how it looks like. Okay. This is an interface with DBMS, monthly report, charts, automated inquiries. So IMS systems are logical interface with DBMS. Okay. So MIS systems are logical interface with DBMS. So monthly reports, charts, if you want to generate monthly reports, if you want to generate charts, automated inquiries, so we go with this. Application development. Okay. Today every non-technical staff use tool to build little programming that you can database. Okay. Database management systems has all kinds of tools to develop custom application programs and interface. Okay. So application development will provide some tools. Application development will provide some tools using which we can build some programs that use the database. Okay. Using with these application tools, we can build a programs that use the database. Right. Example, the colleague Ms. Banner is actually an application built top of Oracle database. Okay. So this is one example. For using this tool, we can develop a database, we can develop a program that is used for database. So in this topic, we covered the definitions of database. What is the definition of database? What is table? What is record? What is row? Okay, and what is database? A collection of data, a collection of tables. Then what is relationship? Right? What is relationship? How many types of relationships we have? Right? How many types of relationship we have? So usually in this database concepts, so these are the few concepts, or these are the few fundamentals may ask in the that is definition of database. What is database, right? And if you can say collection of related data, then they may ask what is table. Okay, it's a collection of records. It's a collection of records. Or you can say it's a collection of rows and columns. You can say it's a collection of related rows and columns, right? So we covered definitions, we covered concepts, we covered relationships, okay, different types of relationships, and what is table. So you can see clear brief description or clear description about the table. Table is a database object. It's a database object or structure where the data is sorted, Yeah. A table will be contain rows and columns. A row is a table is called as tuple, and the column is a table is called as attribute. So generally, when you drill down, all the fields, collection of fields is a record, collection of record is a table, collection of table is a database, okay, and collection of table is a database. And this not only collection of tables, we do have some relations between all these tables, okay, as we discussed, one to one, one to many, many to many. These are the three relationships. These are three relationships by which we can map different tables. Okay, we can integrate or we can map different tables, one to many, one to one, one to many, many to many, right? So these are the, so this is few basic concepts of database. These are the few basic concepts of database. Thank you.